All right. Welcome, guys. Sorry about the slight delay on my behalf. I had a board meeting. It was the first time I really had a meeting outside, and I kind of misjudged the length of the way back. And I couldn't find my damn headphones. But those are real world problems, right? Today we have a really exciting talk. Last week we had the big unveil, or the big launch, so to say, of IOTA smart contracts. The first time there are functional smart contracts possible on IOTA. And it was a really exciting release. We had some great activity from the community, actually, where they've really been diving deep into the Ethereum virtual machine, into WASM, writing smart contracts in Rust and in Go. And it's been a fun experience, simply because now we are moving away from IOTA just being, a transfer layer, to IOTA being a programmable multi-asset ledger. And this is really where we're progressing towards, right? Adding real utility to the base layer and to the second layer, and making it possible for all of you to build, right? That is what this is all about. Empowering everybody in the IOTA community and everybody outside of the IOTA community to leverage the technologies that we've built. And I think this is a really exciting time. And it opens up new opportunities for everybody. And today we have a very, very, very nice talk. First time I'm not doing it alone. That's a big plus, especially for my voice. And we have Dave and Evaldas. Let me actually get them onto the show. All right.
Hi there.
Hey, Dom.
How are you guys doing?
All good.
Change it like
Fine.
this. Yeah, no, it's been a quite exciting week. Maybe you guys want to give a quick intro and tell us about the experience with the launch.
Yeah, it was an exciting week last week with the beta launch. It was actually quite a rush for the whole team to get everything ready and everything up and running. We had a nasty bug the day before the launch, so it was kind of rush. But in the end, we made it, and so far the launch has been going pretty well. Well received. A lot of people are actually excited about it, trying stuff out on the new testnet, running their own WASM nodes. So I'm super excited to see what everyone is going to build with this.
Yeah. Did it turn out better or worse than expected?
Better.
A lot better, right?
Yeah. You always assume the worst, and then it can only be better, right?
That's a good mindset. Evaldas, for you?
Yeah, I agree. It was better than expected, but I agree also with the last comment. Normally, yeah. So actually, it's a second kind of launch for me. So it's a second version. Beta is a second version. Yeah. So I'm very excited to see that the people are taking it and building on it.
Yeah.
And this is.
Yeah, and honestly, like when we went on this quest, right? We started in April of last year. We had the alpha release. Or when was it again? Do you guys remember?
Yeah, more than a year ago.
Yeah.
Yes.
Yeah. And now you can spin up your own chains. You can really build smart contracts. You can build dApps, right? As we see with the roulette had, I think, close to 3,000 rounds so far.
Yeah,
so
nice.
So the community has been busy playing, and we also saw things like TangleSwap and or TangleC, so to say, and the NFT marketplace being relaunched. As well, I think that will be very, very, very exciting. I think maybe we just jump into the AMA, unless you guys have some comments that you want to say about the launch and the experience so far.
No, let's go.
Yeah.
Let's answer some questions, I guess.
Actually, just as an introduction, if compared to the last release, because it's a kind of journey of already 2 years more or less, through several versions, several kind of milestones. So the last one is, of course, the biggest one, and at last we have a really completed concept and completed set of functions in all our software, even if it's not sometimes working as it's supposed to be. But still, the last one is, of course, we have the programmable, fully programmable smart contracts on, and we even have a EVM, which is exciting stuff, meaning that everybody can just run a Solidity contract like in Ethereum and so on. And also we have a lot of internal improvements. Where I think it was all covered in the blog post, but still, for example, the consensus, the virtual machine is brought to the next level, absolutely.
Yeah.
And many other stuff, which maybe we'll cover in the AMA.
Right. So basically, the architecture itself is finalized, and I know that you've been very busy with the white paper as well. Can you maybe give us a quick update on that as well? Because I think that will also be helpful for everybody that wants to really do a deep dive.
Yeah, actually, what it was missing, kind of, there was some, all these concepts are kind of, they are not done in one step. You do it iteratively. So there was all kind of write-ups, including the documentation. By the way, we now have a very exciting documentation, the wiki. It was produced. It covers a lot of aspects, which from the programmer's point of view, everything, but also including the architecture stuff and so on. But what was missing? It's a kind of broad description, general description of the rationale, of the reasoning behind why we do this smart contract this way or not the other, why IOTA is good here, and what are kind of directions where to go, because we position these IOTA smart contracts as a tool for big ecosystems. And actually, we are. It's not only crypto per se, as a let's say, like we know all crypto, but also corporate.
Yeah.
So all these markets are targeted with the IOTA smart contracts, and we have to provide the reasoning why we do these architectural decisions. So the white paper is currently, we hope in a few weeks maybe we'll finish. I'm optimistic, or maybe I'm pessimistic. It depends, but hopefully it will provide these.
Right. And I mean, one thing that really helped me as well to better understand IOTA smart contracts is that it's a framework, right? It defines certain rules and gives you the right components to deploy smart contracts on top of IOTA. And there's some different iterations of it, right? And there can actually be instances of smart contract networks that then launch on top of IOTA that utilize this framework.
Yeah, exactly. So yeah, it's a good way to position it as a framework. It's not that a framework like, programmer's framework. It's more the platform, I would say. It's a very broad, a very rich set of all kind of tools to build a multi-chain environments with multiple chains which can transact without any bridges, trustlessly over the tangle, over the layer one, IOTA layer one. So that's the idea. But of course, the protocol itself is open to many specific details, which are use case specific. Fee-wise, security-wise, VM. I mean, for example, most people know probably already that we support now in WebAssembly with 3 languages even. And we support already EVM in its original form.
Right.
Ethereum virtual machine EVM.
Yeah.
So all of this, it's you look at IOTA smart contracts as a tool, very rich tool for the building all kind of systems, scalable.
Yeah, and I think what I see a lot in the questions actually is people who want to build DeFi applications on top of this, which is obviously possible, but you have to take into account that this specific release is very much aimed towards the core of IOTA smart contracts and not so much towards building out a network with dynamic validators, etc. So it's very much permissioned right now. we're looking into researching this, but yeah.
Yeah, I mean that will be one of the major points also of this discussion, because I think what we have right now is this beta release where you can start building your dApp, and some of those other key questions, right, especially how to do this in a permissionless way, is something that we've been working on for quite some time and will probably share in the near future, right?
Yeah, the permission, it must be explained a little bit. I always, it's important topic. I mean, it's the validation set of the one chain is permissioned, but it doesn't, it's permissioned in a sense that you have to come together to make it, to validate, but otherwise it's not permissioned. You can build, whoever wants to deploy chains, they can deploy chains. Whoever wants to request chains, send transactions to chains, to a level one, to exchange between chains, they are free to do that, and so on. And when we're talking about the permissionless, of course, we're talking about the permissionless validation, when somebody can come with its node and start validating chains.
Right.
So this is also one option.
Yeah. Exactly. For those of you that missed it, or for those of you who are interested in actually diving into IOTA smart contracts, please go to our wiki, and most of the information, most of the important information there, right? The core concepts, the architecture, and all of that is already there. So if you want to get started, this is your best source. So without further delays, we already had a delay in the beginning of this on this show. Let's jump into the AMA. Let me actually reload this. This is a really cool feature now, by the way. I think you can see that the AMA is live.
Oh, that's nice.
Seems like Reddit has it in them. They still innovate. All right, let's jump into it. I have to make sure that I sorted right. Like, should I do
controversial?
No. I remember people always complained if I did best, because it's kind of like a weird algorithm how they do that. Let's do top, right?
What is
that? That was kind of a mistake. Let's go through it. Fuck it. Hi, Dom. It's been quite some time since bigger than Coinbase. I think that was the infamous statement. Are there any news or details which can be provided on this topic? There's no ETAs, right? There's obviously a lot of stuff that we've been working on behind the scenes, including the smart contracts release, right? I think that was a really big one, that is going to open many doors for IOTA and for the community. And other than that, I think some of these statements really become more of a meme than reality. Okay, next question. Can you elaborate more on how IOTA's partners view smart contracts for IOTA? In the past, you've spoken about partners driving a large portion of what IOTA decided to build, but haven't gotten into much detail as far as I know. Now, with the release of smart contracts, it would be cool to hear how you feel this could impact future and current partnership statuses. I think IOTA smart contracts was largely driven and was largely prioritized exactly because of the feedback that we've gotten from partners. Because they've been looking at other solutions in the market, especially Hyperledger, and we realized that we have a really compelling solution here because it combines permission settings, right, while being able to leverage the permissionless IOTA network, and so sort of like the best of both worlds. How do you guys see this? Like, have you gotten any feedback or have had any discussions with corporate partners on this? Like with smart contracts?
I've been too involved with the corporate partners in this. This is also a bit of a broader market. We're also targeting other audiences outside the corporate market per se with this. Like you said, it's kind of a alternative to a traditional blockchain solution for smart contracts, but also a permissioned chain which can be utilized. And I think that can be of use for a lot of interesting projects in that space. But I don't have any specific partner discussions going on about it.
Yeah, definitely. I mean, when we're talking with the industry players, real industries like say energy, so they all the one key point here is that they need scalability through high throughput. I mean, being honest, current throughputs of the distributed ledgers are kind of toy. I mean, 15, 20 doesn't count. So you need thousands, hundreds of thousands, and so on. So when you say that IOTA is coming with smart contracts, it's definitely excites everyone.
Right. Yeah,
this
exactly.
Is positive.
And I think especially for something like EPSI, which is also a question as well, like the European blockchain services infrastructure, where we are one of the finalists. Smart contracts is one of the key components there as well. And so it like this definitely opened doors, like absolutely, like there's no doubt about that. And we're already right now speaking with bigger companies about doing NFT drops, right? I think one thing for people to understand as well, and I don't want to be too long with this answer, but I think one thing to understand as well is like what's exciting about the crypto market, the way that it has evolved over the last year, is that many traditional companies realize now that hey, we can actually use some of these exciting components to drive more engagement for our products, to incentivize our community, our loyal customers with NFTs, with digital tokens, with some kind of reward schemes. And because previously we were kind of stuck in this innovation lab within those big companies, and there was always some uncertainty whether a project gets canceled or gets deprioritized. And I think now with the introduction of native tokenization on the base layer, including NFTs, and obviously smart contracts, we can really drive corporate adoption in a new way. That was very exciting. Yeah.
Actually, yes, tokenization, it's more or less general concept, and also is applicable to the to large big markets like energy markets and so on, because they collect sensors, then they sell those kind of measurements on the markets. So it means that it's tokenized. So the distributed ledger, all of them are looking at.
Yeah, exactly. Next question. What are the differences between layer 1 color tokens and layer 2 tokens, which work similarly to ERC20 tokens? Could you give some examples on why a developer would choose one over the other?
Yeah, exactly. So it's a difference between basically layer 1 and layer 2 tokens. The benefit of using a layer 1 token would be that you can transfer it across two different chains if you wish, or use it on just layer 1 alone, just transfer it to someone else. And with a layer 2 token, ERC20, it's basically locked inside the current chain you are in. So you can only use it there, and you can potentially bridge it over through a layer 1 token to another chain, but that involves some extra steps. So why would you use an ERC20 in this case? Because it's compatible with existing ecosystems. You can use it in the EVM. And in the future, we will be combining those two as well. So you can have a ERC20, which can also utilize native assets. And there will be some more specifications about this soon when we allow this and how we're going to do this.
Yeah, this is we often use some metaphor, which is the bank and cash metaphor. If compared the layer 1, layer 2, so layer 2 tokens like ERC20 or something, which are all on the accounts of the some chain, it's a kind of bank, right? You don't own the token, but you have an IOU. So the bank does it on your behalf, whatever you say with this. But with a layer 1, you can wrap or take out from the bank the tokens like cash, and then you can do it with the cash to have in your pocket and spend whatever you want without any bank. So that's the.
I mean, they're like we could also see them as sort of like first-class citizens of the protocol of the network, right? Because they're the most secure. They're the most feeless, right? Same as the IOTA token. And what, like if I look at the entire concept of what we introduced with IOTA smart contracts, I think this is really the key. Because this is like exactly this feature is what developers in other ecosystems have requested. For example, one of the absurd things today is that you have Ethereum and then you have wrapped Ethereum, because the Ethereum token cannot be utilized within the dApp ecosystem in Ethereum. So you first need to wrap it, and only once it's wrapped, you can use it within a dApp. And there's obviously like huge fees involved in that. Like, for example, just recently I wanted to buy an NFT and it cost like $150. And then I just paid like $30 for wrapping fees. So that wasn't a very efficient process.
Yeah, you can still have wrapping, but that would be like bridging from other blockchains probably, and won't be that relevant to transferring between different chains in ICP nodes per se. You would see basically the ERC20 on a specific node as a wrap of a native token.
Exactly.
Everyone can make those. So,
yeah. So I really think that this is the secret sauce. Like, this is the key ingredient of the architecture that we have. We have layer 1 tokens, first-class citizens, very secure, very fungible. Everywhere where IOTA is listed, you can easily list those tokenized assets then as well. And then we have layer 2, where we have smart contracts with infinite possibilities. And just so everybody's aware, over the next few days or weeks, we are actually going to publish the updated specification for our tokenization framework. So Levente, Max, you about us have also been really involved in that, have done a really tremendous job in updating the specifications for the IOTA mainnet. So I really encourage all of you to then check out the specs and learn what we're bringing, because this is really, really unique to IOTA, and nobody else really has it in this way. Next question. I think it will be great to write an article in IOTA Blog. What is IOTA Blog? I think is this our blog? I guess. Where to it's a wiki.
No, it's a blog. Whatever.
Whatever. Where to present ICP as layer 2 Ethereum. Describe all the advantages and compare with competitors. Just a technical comparison with the rest of the layer 2. If this may seem like an attack on the rest of the L2, one can simply describe the benefits of ICP as L2 Ethereum without mentioning the other L2s. What do you think is a good idea?
Yeah, I personally think it's a little bit too early to do that, because we don't have the decentralized nodes or basically the decentralized validators yet, the dynamic validators yet, like the other networks have. So we currently can only compare ourselves maybe to a hyperledger, which is not super exciting. But we can definitely get back to this topic later on once we're a bit further with that.
Yeah, the layer 2, it's more or less layer 2, like roll-ups or something. The whole advantage is that the layer 2 is connected and anchored to the layer 1.
Yeah. Like what I can definitely say is the biggest difference is the trust requirements between IOTA smart contracts and layer 2s on Ethereum, because the layer 2s on Ethereum, all of them require a bridge of some sorts, right? You have to go from the base layer to the layer 2. And there's always some trust requirements involved in that, where there's a multi-sig and stuff like that. But we can definitely do more education, and once the comparisons are more fair, right? And once we have the permissionless solution published, so that everybody can know what it looks like. Okay, this is a lot of questions. IOTA dollar P2P algorithmic stablecoin powered by IOTA dollar, IOTA trading. Okay, I think he's actually asking a specific question about the stablecoin model. Do it, analyze it live.
I'm not sure. It's not really our task to come up with the use cases, right? We give the tools, and you build a nice algorithmic stablecoins. You can definitely do such a thing with either EVM or with the WASM implementation. So try it out. That's the way you find out if this works, right?
Exactly. I mean, that's the beauty of DeFi, right? Everybody's always ridiculing DeFi for the money that is being lost there. But that's what it's advertised at, right? It's a rapid innovation playground, and everybody's sort of aware of the rewards, but everybody should also be aware of the risks. And I think with stuff like algorithmic stablecoins, first of all, they're super exciting. They're very interesting concepts, and like you have to experiment with them, because there's always some things that you forget that you have to test out in the real world. And we can't analyze it live, but what I can really recommend you is just to build it, right? Or get some people to join the team and build it. Yeah. Can you give us a status update about the finished EPC phase 1? like what I can say is that we published, or we not published, but we submitted all the documents. The presentation that we did with them went very, very well. And right now we're basically just waiting. And I think by the end of November, we will have a confirmation if we go to phase 2 or not. But once we know more, we'll definitely share it with all of you. All right, next question. What changes need to be made to the Tangle to support zero-knowledge roll-up ISCP chains? Valdes, you want to take it?
Yeah. To the Tangle, we don't need any changes. I mean, if looking at the Tangle, the consensus mechanism, to the ledger, UTXO ledger. So I mean, it depends on the purpose. Actually, do we need and in what form we need? We want to do it. But zero knowledge proofs essentially means validation of the zero knowledge cryptographical validation of the layer 1. The implementation wise, it's a type of the UTXO, new type of UTXO, which is kind of locked or can be unlocked rather with some zero knowledge proofs. So it's not big architectural changes. It's a new UTXO type currently. How we are doing in the newer specification is a kind of hard-coded script, extendable script. It's a module new module of the ledger, UTXO ledger. So it's not the big deal. I would say cryptographically is of course very complicated stuff. Architecturally it's not, but the biggest problem with the zero knowledge proofs actually it's not on the layer 1, but it's actually on the virtual machine, and we don't know. We actually didn't analyze it yet very deeply. It's one of very interesting directions where we will be moving. But even now, it's possible to say that the performance penalties on the layer 1 on the virtual machine are huge, and that probably it will become a bottleneck in many aspects for the smart contracts. So yeah, that's the answer. Not much dramatic changes, rather more development on layer 1, and pretty how to say, not easy, not trivial developments on the layer 2. That's the zero knowledge proofs. And yet, of course, the more questions here is about, yeah, there are more kind of about this. So this is about zero knowledge proofs. Yeah.
Yeah. I mean, the very exciting part about the new protocol upgrade with tokenization and with output types is that it can be extended, right? So right now we have output types for, I think, for NFTs, the token foundry.
Yeah, maybe it's a good time just to mention it. So because it's related to, for example, the question here I see number 3 in the same line of questions.
So just real quick, the question was, how difficult would it be to integrate Cardano's extended UTXO model?
Yeah. So actually, it would be pretty much straightforward. And actually, we, in a sense, we're doing this. However, we do not see it as a scripting like in Bitcoin or Cardano, because we don't see it as a good mechanism for universal smart contracting. It's for specific reasons. But if you have a specific reasons, you develop them on the layer 1, you put it there into the, because it's every node has to run it anyway, it's layer 1, right? Yeah. So you implement it when you know why you implement, and we implementing it as a UTXO types, so-called. Each type you already mentioned. So there's some kind ordinary type, like so-called extended output, transfer of value. Then there is an alias output, then there is an NFT output, and then there are foundries, which means tokens and so on, so on. All of these are some kind of scripts or state machines which are configurable with all kind of data. It's kind of in between traditional UTXO and the what is called the scripting, full scripting, like on Cardano stuff. So this is our approach.
Don't give away too much yet for the for the new specs.
Valdes is leaking the alpha here.
No, it was discussed. I think it was
I'm
discussed
joking.
on Discord. Whatever.
I mean, it's really important to talk about this stuff because they're so exciting concepts, and IOTA smart contracts makes a ton of sense when you think about layer one. The second question here was, how secure are version V1 IOTA smart contract chains compared to side chains, Plasma, optimistic rollups on ETH with regard to trustlessly enforcing ICP disputes?
Dave already said it's early to say when we will implement this optimistic game theoretical security, which is just asked about. Then we will compare more secure or it's not. It's one of directions we are going to.
Yeah. I mean, it should be important to emphasize here that the objective is shared security, right? Every smart contract chain that is deployed on IOTA, on top of IOTA as a layer 2, has the same level of security as the base protocol, right? It's as secure as the IOTA network.
Not only same level, but same source.
Right. Yeah.
Security.
Yeah. And that's probably a big comparison to sidechains and rollups. I'm not sure. Like, I think the only ZK rollups have shared security, if I'm not mistaken.
The principle is different. They because the optimistic rollups are running on the so-called fraud proofs. So you are optimistic. You're doing transactions, and you can prove it was wrong. Probably kind of that. But with zero knowledge proofs, it is a different approach. You are actually providing the validity proofs, not fraud proofs. So this is a kind of dual. It's not immediately comparable.
Yeah, but what we're going for is similarly to Polkadot, how they have this shared security between parachain and relay chain.
Yeah, like in Polkadot, the trust layer common for all is so-called, what do they call it? Master chain or what? I don't remember.
Relay chain.
Oh, relay chain, yes. And for us, it's a tangle.
Yeah, that analogy makes a ton of sense. Any updates on the Oracle development? Is a potential integration of a decentralized Oracle network planned?
Yeah, so Oracle's super important building block for the whole DeFi ecosystem, and also for anything smart contract related, of course. We had the streams-based oracles released earlier this year, which is already like a single data source, but we don't have any specific updates at this time. Like I said, we're very early here with the integration. We just have the core things done, and now we can start building upon that and adding things like streams integration or other interesting concepts that will allow us to easily get Oracle data, maybe a direct connection to a existing chain like Ethereum, so we can get Oracle data from there as well. Those are all things that we can look at, and this is not something that's limited to what we're doing in the IOTA Foundation ourselves, but this can also be done by third parties. We might even talk to some other parties about providing oracles or Oracle software that runs on the IOTA Tango with the EVM compatibility. It should be pretty trivial to use existing solutions there. So everyone is free to deploy a open Chainlink based system or something like that.
And this is probably like an important thing to also highlight. Like, we need to have this mindset change as well, right? Like, if there's something missing within our ecosystem right now, it's an opportunity. It's an opportunity for you to build and to really launch an exciting new product, right? Because there is a gap in the market right now, and you can fill that gap by building a product, right, and launching it on IOTA. And I can really encourage all of you to get into the builder's mindset, because there is like IOTA is opening up now, right, and the ecosystem has been really extended with real utility, and now is the time to build it. And of course, we'll also be working on partnerships with other Oracle networks. But all of you are also empowered to build, right? Will IOTA as a layer 0 in the future be able to support more smart contract languages on layer 1 than the initial 3? Thinking about Pluto smart contract, for example, ADA.
Well, we don't have a layer 0, layer 1 smart contracts right now. We have the WASM-based smart contracts and EVM-based smart contracts on layer 2.
Yeah.
We don't have programmable smart contracts on layer 1. There are some thoughts about this, but there's nothing concrete to be implemented at this point.
I mean, yeah, like I think the thinking here is that IOTA is layer 0 now, right? I think this is something we also have to get more on the terminology, because obviously IOTA can be used to
What is layer 0? We normally what you find in the crypto space is layer 1 and layer 2. The layer 0 doesn't exist.
I think, I personally really love that comparison, because IOTA is not a layer 1, right? IOTA is actually becoming this base layer, this foundational layer where you can build new layer 1s on top, right? If there were a smart contract network on top of it, like, is that now a layer 2 or is it a layer 1, right? It's kind of interesting, right? But the point being is we just integrated assembly script today, no?
Yeah, we now have support for assembly script, Rust and Go, which compile to WASM.
Yeah,
and it was a fairly easy thing to do. Apparently, I didn't build it myself, but it was Eric. But it's pretty cool that we can add those new languages, and we can add many more on the layer 2.
Yeah, exactly. So the focus is definitely on extending the possibilities of building smart contracts on top of IOTA, and we don't want to bet on a certain language, right? We're not going to say this is better than the others. We just want to enable it so that all of you have the flexibility to build, right? Next question. In the blog post was written that the smart contracts building will also be possible in modular system for beginners. Will there be any tutorials will that feature be implemented in the Firefly wallet, meaning you can create some easy smart contract casual on your mobile device soon? Thank you for your work.
I think this is about the schema tool. And basically what this comes down to is you create a structure of what functions you would like to implement in your smart contract, some variables, and then it generates the code for you. And this is something you could implement in a user interface as well, so that you can basically drag and drop your layers together. This is not something we offer right now, but theoretically this could be possible because of this way how we construct boilerplate smart contracts with the schema tool.
Yeah.
What was the other part of the question?
If it will be integrated into Firefly.
It probably won't be integrated in Firefly. I mean, you shouldn't put everything in there, especially not if it's not directly interacting with maybe only for deployments or something. But I think maybe a separate web-based application would be fine for that. That could maybe interact with Firefly for signing a transaction or something like that.
Yeah. I mean, developer education and learning and the tutorials and stuff like that is super important. So we will definitely put a big focus on that. And I guess Firefly, we can integrate the assets, so you can easily interact with smart contracts from Firefly, right? Similarly to MetaMask as well. But other than that, like the tutorials are already out there. So please go to the wiki and there's a lot of stuff there. There's also some YouTube tutorials that Kumar has been working on. So a lot more will come. I don't think you will ever be able to deploy a smart contract from your mobile. I'm not sure if that's a good use case.
I mean, to deploy, we can implement. You take a ready-made and you.
It can be done, but does it make sense?
It doesn't make much sense then, though. Yeah. But
just walking around, launching my smart contract.
Yeah, Firefly is actually a crypto wallet. It's not tool to working with smart contracts per se.
Yeah. But to the point of the question here, developer experience is everything, and so we're definitely focused more on that. Next question: there's on-ledger requests hooking into layer 1 with a hash, right? It's just a transaction. Versus off-ledger requests where you just call a WASP API instead. What are the use cases for both, but mainly the off-ledger requests? Who would need such a setup? How will it be secured and be maintained?
So you want to answer this, Evolis?
No, okay, go ahead.
Okay, so basically in the alpha version of smart contracts, you only had on-ledger requests. What this means is you post a message to the Tango, which contains the instructions for the smart contract you want to execute on a certain chain. This is being picked up by the WASP node and executed. So basically, you have to post a transaction, do some proof of work to do that. The transaction has to be picked up. That's all a bunch of overhead, and you basically request something on the layer 1. So that's being utilized. With off-ledger requests, instead of posting something to the Tangle, you actually directly communicate with a WASP node on the layer 2. So you already know what chain you're going to work on, and you basically talk to the WASP node and tell them, okay, I want to execute this smart contract. By doing this, you bypass the layer 1 transaction. You don't have that overhead. And also the layer 1 doesn't have the overhead for posting the transaction. So in terms of scaling, this is a lot better to interact using off-ledger requests. Why would we still use on-ledger requests then? Well, if you have to transfer assets from layer 1 to layer 2, you naturally have to create a transaction as well. And a on-ledger request can have tokens attached to them from layer 1. But for the majority of the requests, you will be utilizing off-ledger requests, with the exception of where you have to transfer tokens, or maybe cross-chain transactions where you don't know the WASP node entry point you want to talk to.
Yeah, I would add, if you're talking about the analogies, similar things in other popular blockchain platforms, smart contract platforms. So the what we call off-ledger request, it's kind of a little bit strange maybe name, but it's analogous to just posting a transaction to Ethereum blockchain. So you take a node and you post the transaction there. So then miners are doing this stuff with it, including the blocks and so on. So this is an off-ledger request. And the main use case is having high throughputs for each chain. But we have here multi-chain environment, not one chain. So we actually introduce the concept of the requesting, more or less with the same semantics, on ledger, meaning that one smart contract on one chain can post a request for the smart contract on another chain. And then it goes as a transaction. It's of course, it's again, the question of throughput, of scalability, because it's on the layer 1, on the Tangle, while the off-ledger is much, much faster. But in general, they are more or less equivalent security-wise and function-wise.
No, I think one important thing to maybe also ask here is about MEV, right? Minor extractable value, because that is a big problem that existing POW blockchains have, like for example Ethereum, right?
Yeah.
Can you maybe explain the problem a little bit that Ethereum has and how we solve that, or do we have the problem?
Yeah, how I see a problem, the miner takes whatever he wants, any requests, any transaction proposals, and then it generates a block, right? And then the miners compete which block will win because of proof of work and this stuff. So you can include whatever you want, and then you analyze the incoming stream of other transactions and take advantage of it. The miner, it's so-called sandwiching, when you put before transaction, after all, or front running, you do something on the asset which someone posts some sell by, so you do before something, taking advantage of it. So yeah, it's I think, for me, it seems it's an inherent problem of the proof of work blockchains, of the permissionless setup and the structure of the consensus. We made some provisions to eliminate or prevent, let's say, this problem specifically, because the smart contract chain, IOTA smart contract chain, is validated by the some finite set of the miners. They could do something like that, right? But it's not, because actually they are coming on consensus, not on the block, but actually they are coming on consensus on the input batch. And after they coming on consensus, they run batch, and nobody can influence the, because it's a consensus. And it means that at least in this form, the minor extractable value is prevented. Besides, we sort it randomly the batch, so no validator node can influence the content of the batch and the order. So it eliminates at least this part of the minor extractable value.
Yeah. No, I mean, that's a really important point, because in some of those other networks, it's the users versus the validators, right? They're sort of like in competition as well. And we need to secure both, right? And provide incentives for both. Next question. I've been heartened. That's a good statement. By your recent comments acknowledging the importance of permissionless smart contracts and hints that they are already being researched. Might the community expect sneak peeks into implementation ideas within the next 2 months or so? Or is 2022 more likely? Is it contingent on first completing some other prerequisite technology, perhaps also still in development? Or is it more a straightforward matter of applying the researchers' time and quarters? What I can say is that we've been working on this for quite some time. It's a very obvious path for us to take. Like if you look at IOTA smart contract as a framework, and you look at IOTA as a token ecosystem, it's kind of obvious that there needs to be a permissionless way for you to deploy smart contracts. We can't share when we will share this. I think we've really moved into this mindset of not giving ETAs, but we will definitely share as much as possible. What we can share now already is that the tokenization framework will be published over the next few days/weeks. And one exciting avenue that we're looking at is obviously how to enable this shared security. And we will be sharing more on that soon. The famous word. They'll hate me for saying that.
Oh yes, sorry.
You should get a trademark for that.
Yeah, totally right.
They have. Yeah,
we need to put those memes on our shirts, like soon bigger than Coinbase and
NFTs. You have to have an NFT for that.
Oh, right.
If Aldous gets it.
Yeah. The committee itself but then there can only be one soon, and then we have kind of a problem. Copyright problem. Next question. The committee itself can also be variable in size, from a few nodes up to hundreds of nodes. And each node can be part of many different committees. First question. A committee cannot have thousands of nodes. That's the question.
Yeah, there's a limit to the amount of nodes that can talk to one another and form a consensus because of how much they communicate with one another. And how much they will have to communicate. And this gets more complex the more nodes you add exponentially.
Yep.
So that's why there's a limit to the amount of validators you can have at the same time. Maybe if Aldous can talk a bit more about this, he's a bit more in depth about this stuff.
Mm-hmm.
Now, actually, we are in the realm of so-called Byzantine fault-tolerant consensuses. So this is a consensus used everywhere in rollups layer 2, in Binance Smart Chain, in Polkadot, in many. So actually, the very key fact here that you have some kind, by the very nature of the consensus, you don't have thousands of nodes.
Right.
Probably, and also if you have more, you have always a penalty on that. Because if you look at if there is one person in the room, it's very easy to get to consensus because there is only one. When two, it's all more or less possible quick. But if you have 100 persons in a room, you will have a lot of time to waste to come to consensus on it. So this is a basic reasoning. Actually, talking about the BFT consensuses, and we using Honey Badger, I would say it's a kind of 30-50. It's probably the practical range, but we actually never did a benchmarking at the higher end. And of course, and also we have to take into account, because this field is it's very old, but it's very complicated, and it's advancing. So we are not, the protocol itself is actually more or less agnostic about the consensus.
Right.
Yeah, so we will progress with the advances, progress in this field too. So
Yeah.
we will see. And also finishing. So actually the security stuff is not about the number of validators, but actually what they do and who they are.
Right.
This is a more important stuff. So this is the answer. So, but
Yeah.
short answer, 1,000 is probably not possible with this kind of consensus.
And I mean, the consensus is stuff that has been resolved and has been solved, right? So to say, has been researched over the last few decades. And as you mentioned, we can always replace it in one way or another.
Yeah, that
Yes.
as well. But also, like Evaldo said, the security is not based on the amount of validators, but more at what is at stake for them.
Yeah.
So if you have 1,000 validators that all only have one IOTA, that has less of a security than if you have 30 validators that all have 1 giga IOTA, for example.
Right.
So that
Yeah.
you have to take into account as well. And you can also come up with more creative solutions, which a lot of other protocols are doing. Like, for example, delegating a stake of your tokens to a certain validator, so that you stand behind that validator with your stake and they represent you while not having to be a validator yourself.
Yeah. Yeah, exactly. The next question is, what is the maximum number of WASP nodes that can be in the network? If there is a limitation, what is the reason? I don't think there's a limitation. There's no limitation.
There is no limit.
Yeah. And I think this is also, like, one of the very exciting things about IOTA smart contracts is the validation that can happen with it, right? That the infamous statement, trust but verify. So if you join a smart contract chain, you get all of the decisions that are being made by the validators, right? By this sort of committee. And you can actually detect if things are not being done right? And you can then also give sort of fraud proofs, and act on that.
Yeah, that's exactly the idea of the optimistic rollups too.
Yeah,
they went through the several also kind of steps or stages of development from Plasma to optimistic rollups and so on. But it's all based on fraud proofs, and the fraud proof is actually based on the idea that the virtual machine, the state transition, is a deterministic function.
Right.
So if you do everything, you can check if the output is the one which is supposed to be, or there is something which is not supposed to be, like stealing funds. And it's detectable, then it means someone can punish for it. So this is a basic idea.
Yeah. Yeah. And it only needs one node, right? That's also very important to keep in mind, because we always talk about availability of the data, right? I think that's a very important concept as well, because that gives censorship, right? Having thousands of nodes that have a replica of all the data of the blockchain, so to say, and you only need one node that actually keeps the data, because you can verify all of the state transitions through IOTA, right? Everything is embedded in this global trust layer, which IOTA is. So with the data that you receive from one node, you can then verify it through layer one, and then synchronize with the network. And you can also then rebuild this sort of smart contract network. But it's like a detail, a very exciting detail, though.
Yeah, it's actually the idea is that you have a state, so-called chain state, and it is committed on the tangle on the layer one. So it's immutable, and it's enough one copy to rebuild the whole state for 1,000 nodes if you want.
Yeah, exactly. Yeah. Can I create a committee from all available nodes on the network? As Evaldo has mentioned, the feasible number is probably around 30 to 50 committee members. Because as was mentioned, the number of the committee members is not the important thing about the security. It's really about what they are doing, right? and how they're being incentivized. I think that's sort of the key here.
Yeah.
Next question: can you address ISCP's ability to IOTA smart contracts ability to replace the Lightning Network and other proposed solutions as Bitcoin's transaction layer? I think this aspect needs more exposure and attention.
Yeah, I'm not super familiar with what the Lightning Network is doing. I think it's just sending transactions on a second layer, right? This can easily be.
It's like bidirectional payment channels where you just sign the transaction and you like have these payment hubs that then route the transaction around, basically, instead of selling it on the base layer, on the Bitcoin layer.
Yeah, you can do something similar like that. You can definitely just have a whole payment layer on a layer 2 with smart contracts and expose the state there and make it scalable like that. We need it less as what Bitcoin needs it for, because we are not we don't have that many transactions right now. We're not on our limits, but it can definitely help out there for sure.
Yeah. Like that's definitely a use case you can build with ISCP. So the answer is yes. It's definitely a replacement for it as well. You can do anything with IOTA smart contracts, right?
Yeah, like the idea of we were always targeting the so-called Turing complete computation model, which was made popular with the Ethereum, meaning it's not Turing complete. It's a more theoretical concept, but it's like you can program any algorithm. That means. And this gives a lot of power, and it's actually equivalent to what we are aiming at. It's equivalent to what Ethereum smart contracts can do. What we can do more, we can do it in the multi-chain environment without adding additional trust, which means that you can run parallel smart contracts. The key point and the stopper scalability problem, it comes from the fact that you cannot run parallel smart contracts on Ethereum. It's by its nature, because it's all synchronously on the same state. But then you need sharding or parallel states. Let's put so the shards here are chains, unlimited all kind of unlimited amount of chains, and then you run parallel smart contracts on parallel chains, and they can interact without any added trust. They become composable, not exactly in a way like smart contracts on one chain. They just call each other and so on, but still composable, because they are how to say, if when you are sending the request, the assets, you are guaranteed either they will come back or it will be processed according to the rules prescribed by the target chain. So it gives new dimension to all of the smart contract world. Let's say.
Atomic composability.
It's not completely atomic. if you talk, there are some discussions. I also participated. So because the people are stick to some definitions, what I wouldn't call that atomic, but who cares? Let's call it quasi-atomic, because the function is here. You don't add a trust. You are guaranteed about what will happen on the other end.
Just so everybody's aware, Evalis is very, very precise about his definitions.
Sorry for that. Yeah.
It's all good. But I think for everybody, atomic composability really makes the most sense, right? Because even like the founder of DK also recently said, it's not really zero knowledge proofs, but it's more like fraud proofs, right, and stuff like that. So you also need to have the right terms, so to say. Let's do two more questions, and then we can all build smart contracts, right? How do smart contract code verifications occur now in the future as ISCP expands support for smart contract languages?
Yeah, that's a good question. You basically you should see there's two things right now. You have the WASM-based smart contracts and the EVM-based smart contracts. On the EVM-based smart contracts, you have the same concepts as on any other EVM chain, basically, that you can upload your source code to a explorer, and this explorer compiles it and verifies it with the bytecode submitted, and then verifies that the contract has not been tampered with, and that is the source code that you supply to the block explorer, where it displays the source code of the smart contract. So that's a validation for the smart contract on the Ethereum chain. And for ICP, for the WASM part, we are actually thinking of bundling the source code with a proof that the source code matches the bytecode or basically the blob for the WASM contract, so that the actual smart contract source code is also part of the uploaded smart contract itself, so that it doesn't even need a specific verification service like you need on Ethereum, but that it's verified by default when you upload the smart contract.
Yeah, I remember there was a discussion on Discord and community whether it's possible to put, let's say, a repository from GitHub right together with the smart contract. Yes, you zip it and you put it.
That's funny.
No, it's kind of a joke. I don't know.
I know.
It doesn't make really sense, but maybe.
We can run
it's
Git
an
on the
important
Tangle.
topic because it's all about verification, right? Verification that why do you need a smart contract? Because you don't have trust. How do you get trust? By providing transparency. And if people can't read your smart contract, then there's no transparency. That's why all the contracts on Ethereum that are non-malicious, they are all verified and you can read all of them. And we definitely do the same for ours. And it's a bit different, a bit difficult with a binary blob in WASM, so we definitely need to provide the source code with that as well as part of it, so that it's very easy to just see what's going on there and being able to verify easily that source code actually matches the binary that you're getting.
Yeah, totally. Last question: how can someone using a DeFi product on ICP verify the track record of the committee members? Do they just have to trust them?
Yeah, so at this point with ICP, we solve the core logic of providing smart contracts on top of IOTA, and we don't provide the logic yet for the whole security, basically the economic security of the chains. So basically what it comes down to now at this current stage is that you will have to trust the verifiers of the committee where you're executing your smart contract on. And at a later point in time, when we're looking at this now with the research department to come up with a solution for getting some kind of dynamic validators, so that you don't have to trust this anymore per se, that you can maybe have an overview of the amount of value at stake before something goes wrong. And
right. And I mean, this is really where the permissionless version comes into play, right? The validator selection. And one of the exciting parts is that you can definitely do things like trust scores, right? And you can also see all the actions of the validators in the past, and if they have misbehaved, if they were not really reliable, that information is also verifiable and is visible.
Yeah. Also, question I a little bit understood a little bit differently. That about the do we have a auditable trace of what's happening on the chain? So yes, we have everything which is needed, but it's more of a result of the consensus of the validators on the committee, because they provide a signature together. So it's a proof of the consensus, but not of individual one.
Yeah,
I mean, totally. You have all inputs, all requests, everything. So you can check if you want to and compare, yeah.
And I mean, this is really where you as a DeFi builder should not worry about these things, because this is what the protocol should take care of, right? If there's a committee members that went offline, the protocol should take care of replacing that committee member. If one is is misbehaving, they should be punished, right? And this is what the network takes care of. And I think like this is maybe also an important message for all the builders out there. Like, the exciting part about IOTA smart contracts is that it gives you this flexibility, so you can define the parameters of your own smart contract chain. But the network or the protocol is also meant to take care of some of these really important security functions so that you don't have to worry about, oh, like how do I actually select and replace committee members right now? This is being taken care of. So the objective is that you have the similar experience as in Ethereum, right? You deploy your smart contract and you spin up your node, and then you deploy your smart contract and you have the address, you interact with it, you integrate it into your dApp. And if you want to be more fancy, you can set up your own smart contract chain. But the important security stuff and the incentives and all of that will be taken care of.
No, it's all about flexibility. Either if your own permission chain, and you can also say, I trust. I'm a consortium of certain manufacturers of certain products. I want to work together with my competitors, but not trust each other individually. So you can set up nodes amongst yourselves and then have like a private chain, which is anchored to the IOTA tangle. That works. And if you want something like DeFi, then you don't trust anyone, and you can set something up, which is like the dynamic committee, which we're researching. And I think it's super powerful that both can be combined as well. So that private chain can actually communicate as well with the public chain if it needs to. And that opens up a whole lot of additional new use cases, even in the DeFi space.
Exactly.
Yeah. No, I think that was a lot of fun, and it was very, very good questions. So thank you everybody for asking those questions. Do you guys have any closing statements? Anything you want to say? Maybe next steps or what the focus is from your side?
Yeah, sure. We can talk a little bit about the next steps. So now with the beta out of the way and the core in place, we're actually starting to look at improving our EVM support, but also porting our code to the Chrysalis mainnet. So that's quite a big refactor because everything is based on Shiener right now. We need to implement the new tokenization framework, which is currently being drafted and which will be public soon. So all those things will be part of a next release, and we're already making good progress with that as we speak right now. So I'm super excited about seeing that, and especially with the new tokenization framework. I encourage everyone, once these specs are out, to definitely have a look at them because they're super exciting if you actually see what's possible with it.
Yeah, so Dave already said everything I wanted to say. Actually, no, but that's true. The next step will be, Goshimer is kind of experimental still platform. So now we're bringing it all with all experiments. We learned a lot and we invented a lot of very exciting things, especially with the UTXO stuff and with the support of the chains, everything. Yeah. So now we're bringing it even with a more expanded functionality and possibilities, especially with the tokenization, advanced tokenization features to the actually platform which runs the mainnet IOTA. And this is very exciting. I'm looking forward. This is a huge work though, but okay.
We'll make it, right? I think this will be the biggest utility upgrade that IOTA has ever seen, right? It's a combination of layer 1 tokenization and output types, and then obviously the infinite universe of smart contracts on top of IOTA. So you can't get bigger than that. Yeah, you're launching blockchains on top of IOTA.
I mean, multi-chain.
Multi-chain. Yeah. No, but thank you, Ballas. Thank you, Dave. That was really, really insightful.
Thank you.
And for everybody who's been watching, make sure to join our Discord. And if you have any questions or need input, we are here to help, right? And we want to get into building exciting innovations in DeFi, in NFTs, and also especially with the DAOs, right? Like we've like the community sort of built a real DAO working group. And now we can start to deploy them. We can start to experiment. And this is really here, like we are really here to encourage all of you to build, right? And to do this together with us and to do this together with the community, because I think that's what makes the most fun. And it's the most exciting, right? So yeah, no, but thank you guys. Other than that, I think we covered it all. Very exciting update, very exciting roadmap. And without further ado, enjoy your evening and see you on Discord, right?
Thanks, Dom. Thanks everyone for watching.
Thank you. Thank you, guys. Bye-bye.